production planning. The webinar will be about 16 minutes and it will be in English language. So that means we are using the opportunity to see the presentation and demo directly from Siemens representative and authorized person. And from the registered companies, I have seen that there's really a lot of companies from all over the Baltic countries. So why we are doing this webinar? Very shortly. One, because we are strong, Columbus is strong in the manufacturing itself. This is the vertical of the Columbus. Then a second one, that we are getting a clear signal from the market about the interest from the companies to investigate solutions which would help to coordinate and to handle complex production and planning process. And the third one, that we have validated values which this solution gives, not only from international implementation, but also from implementation here locally. So, and you might find several case studies in Columbus web page about those local implementation. Organizational part of this webinar. Webinar is recorded. After the meeting, you will get the email with the link where you can download the recording and the slides. Another part of organizational matters, if you will have questions, please write here, and I, as a moderator, will either of them accept, and we will try to answer the questions online, or we will answer those after the webinar. So if you would have a question after this webinar, so please reach us out by the contacts which will be provided in the slides, basically on the last slide. Or if you are already a Columbus customer, so you can contact by your primary contact. So thus, having said that, I'm introducing Michal, who has the experience of more than 50 implementation worldwide. And really, let's start hearing Michal. Michal, the floor is yours.
Good. Thank you very much, Davidas. Hello, everyone. As introduced, my name is Michał Pręczyński. I'm responsible for implementations at our company and implementations of advanced planning and scheduling software. What I would like to do today is to give you a little bit of an introduction to what kind of problems we want to solve, how we can solve them with Preactor solution. We will include a little bit of a live demo just to show you a couple of live scenarios and live planning scenarios. So how can you deal, for example, with a high priority order within your schedule, and also how you can optimize your schedule, for example, using the minimizing of a changeover times. Once we do that, we're going to go back into the slides, and I will show you a little bit about the benefits that you can expect from implementing of a software solution. So let me start with the first couple of slides. So really the first part is a little bit about relating the problems that we see in the production planning. So the production planning, as we understand, is generating the sequence of operations and sequence of orders that you want to produce in a manner that would be effective, meaning that you adhere to requirements of your customers in regards to delivery performance of your orders, or sometimes in the aspects of trying to optimize your schedule to have an effective way of producing. I want to start with talking about the problems, because what we see from the companies that we meet on an everyday basis is we first start to talk about the key challenges they have inside the production planning and scheduling. And once we establish that, then we can relate that to the specific functionality of the systems. Of course, what I understand is that many companies will have very specific problems that relate to that area of the production planning, but I hope you can see some common traits within that presentations that also apply to your specific situation. I wanted to use a real-life example because that's probably easier to relate for everyone, and this is something that I did many years ago when I did probably one of the first implementations of advanced planning and scheduling systems. So that was over 10 years ago. But I use that example as a sort of a benchmark to see how other companies look at the scheduling software itself. So the manufacturing company that here is in the question, they had a very specific problem. They were in a very good situation. They had many customers, they had a very new equipment, but they started to see a change in the market requirements. So basically, before that change, they could see the orders being very long for very large quantities, and the production was quite steady. But the change that happened was that the customers started to require from them as a producer a very short lead times, a very quick answer on the question when we can deliver the order, and also started to order smaller batches because they wanted to minimize the stock on their site as well. So what the company did is that they identified the problems within their organization, and one of the problems that they have seen was with the process of production planning. One, because they didn't use tools to do that production planning, and B, because the process itself required a change. So they went through understanding the market requirements, understanding the what it means for the better process in regards to the business requirement, and they started to look for a software that could help them. The main goal of that company was to help the planner in a very make-to-order environment, where they had those many products, very much different variations of the product, smaller batch sizes. So all of that accumulated to having a lot of orders that needed to be scheduled on the production by the planner. There was a great pressure on the planner from a very dynamic sales department to answer on delivery promises very quickly, and that started to be a problem with the time question. What they were looking for when they were looking for software was also to have that additional flexibility when they generate the production schedule. So they didn't want to have one technique of production planning. They wanted to have some options to do what-if scenarios. So for example, if a new order comes in, they wanted to see which orders they need to move into the future, and which orders can they move into the future, and how this high priority order will affect their whole production schedule. So there were some basic requirements that they have set up, and that's what they requested from the planning and scheduling solution. They wanted to combine the delivery performance, which was very important to them because they were strictly make-to-order company, but they also had to look at the aspect of optimization in order to look for those cost reductions. So in their case, it would mainly mean trying to minimize the changeover times, but at the same time to look for that delivery performance. They have requested to integrate the scheduling solution with their new ERP system, and they also wanted to introduce a concept of priorities. What they have seen in their current process was that usually the salesperson that shouted the loudest got the highest priority for a specific order because they had a power over the planning department. What they wanted to do during the implementation is to have more flexibility in regards to that priority setting, or rather less flexibility, because the management was supposed to set those priorities in order to exactly see which customers should be supplied first. The main problem in regards to the process itself, as I mentioned at the beginning, they were looking for a better tool to schedule their production, but they were also looking for a better process. When we came into their company, what they had was the situation when they actually had 3 different planning departments in each of their production departments. All of those people had to negotiate with each other in regards to when they can deliver their part that was needed for the full final product. So the company wanted to go away from that decentralized planning responsibility into more central schedule. And just to give you an idea about the situation that they were facing in, is that when the sales department had a question concerning the delivery, when we can deliver this specific order that we want to promise to the customer, each of those planning departments needed about 24 hours in a sequence in order to answer that question. They were using locally Excel spreadsheets, so each of the departments had to download orders from their legacy ERP. They had to establish that sequence inside the Excel, and then they could pass their work to the next production department for them to validate when they can expect those sub-products to arrive. They would establish their sequence. They had about 24 hours to do that between each of those departments. So what finally come out of this when we were doing the analysis, looking at their planning process, is that in total they needed about 3 working days in order to be able to answer to their customers when we can deliver this order. And that was unacceptable waiting time for them, because as I said, the market requirements that change require them to answer that question very quickly and not to wait this amount of time. So they needed a change in the tools they were using in order to get away from those Excel spreadsheets when they had to do the sequence manually, but also they wanted to change the process itself. Out of this implementation, as I said, I'm using this as a benchmark, and we're going to go back to that story that this company has achieved by introducing advanced planning and scheduling solution. But you can see what we have seen from different companies is that we see those challenges that are quite similar. As I said, you might have different types of processes, but those challenges can be similar. So, for example, one of these challenges inside of the planning department is what we just noticed in that real-life example. It's about relying on those manual tools or semi-automatic tools like Excel. They usually rely on the planner, and this is what we call all in the mind and the hands of the planners. What it means is that the planner has to set the sequence of orders that they want to produce on each of the machines manually or semi-automatically in case of Excel, but they also have to remember about all of those additional resources, additional constraints, as we call them, that are needed to be taken into account. So, for example, a specific sequence, let's say a sequence of colors that needs to be taken into account if you want to optimize the schedule and minimize the changeovers. They have to remember about specific priorities for the customer. So it's really about relying on that planner or planners, if you have more than one, remembering those production variations that you have and all of those constraints, and then trying to do the manual schedule in Excel. Some of the companies will also see little support from their ERP systems in regards to standard functionality. This basically deals if you have a simple capacity planning when you try to set how many orders you will be able to make in a week, but there is not enough details for most of the companies to actually use it on their production, because they really want to see what they will be doing on each of the machines. The other problem, especially what you see in that real-life example, was that central planning approach. So when you try to decentralize the planning responsibilities, you come up with a situation when you need a lot of arrangements between different departments and different planners. Not only it takes time to do it, but also you spend resources on negotiations that you need to do. You do not necessarily synchronize the operations between different departments, and that could be also a problem within the production planning. The other point is that when you do not see enough details in your production schedule, you don't see the representation of your actual capacity. So you don't see how many people, for example, you need in order to make that schedule, or if your people operators are a constraint, how many you have them and how you have to adjust the schedule because you have a maximum number of operators that are available. So usually in those manual systems, you don't have that visibility. And also, if you really want to speed up the process of preparing the production plan, usually in those manual systems, you don't have that approach with the automating of sequencing, and especially if you add additional complications such as the need to optimize the sequence, this can be also another challenge. So most of the companies, they would deal with that with trying by really doing a very short planning into the future. Because if you, like in that example of that customer, when you increase the number of orders that you have, you increase the number of operations that you make, and you don't have enough time and you don't have enough resources for the planner to actually prepare that sequence manually, what you will see is that you will have a short planning horizon. So you start to promise delivery dates in the future, for example, in the next 2 or 3 months, but you can only see your production schedule for 1 week. And what that means is that whenever you have a change, such as new priority for an order, or you have a machine that is broken down, you will run into a problem that you're making some changes in your short-term schedule, but you don't see the impact on those orders that you have already promised in the future. All
so
that
in
leads
other words,
into...
Michael, sorry. So in other words, you say that the trend from the market is that customers are demanding more, let's say, faster responses from the producers on the, let's say, the order, then it can be delivered. And another trend that the planners, they feel the pressure inside to provide faster answers with more details.
Yes, that's exactly what we've seen for many years when we talk to those companies that are having those challenges in the production planning. There's pressure from the market that translates into the pressure internally on the planning department to make everything quicker and to quicker provide that answer when we can deliver, but also not only to provide it quicker, but to keep that promise, and also to be able to show how it will change if those internal things happen, such as a breakdown or a new priority order. All of this can lead to the due date performance problem. So what you can see is that if your delivery performance goes down because of that ineffective production planning, this again creates a situation that you want to deal with. Out of those problems comes basic functionality that is needed for scheduling system. So you can see that in order to tackle the problem of having everything in the planner's head, what you need to do is to go on the more have a possibility to do that schedule more accurately, to look at more details in terms of the machine level. Of course, when you look at more details, that means that you need to have some kind of a planning engine in order to automate the schedule, because you add more details, and at the same time you want to keep to those details, such as looking at the operators, looking at the tools, or looking at the setup times. The other important point here is that you have to be able to integrate your scheduling solution together with other systems, and that's mainly your ERP solution. Scheduling system should never be considered as a transactional system that holds all the master data. It should really work closely with your ERP system, where you have your orders, where you have your routing, so all of the operations, and then when you have additional informations that are transactional informations that can be used in order to send to the schedule and then do the production plan. The other option that we are looking for here, we've mentioned those make-to-order companies that would rely on planning by due date, but also to combine that due date with different priorities in order to prioritize, for example, some of your higher level customers. And also to look at the minimizing changeover times, because that comes up very often, even with the make-to-order companies, how we can combine those two elements, the due date performance and minimizing the changeover times. In order to model the capacity of your factory, what you need is to also look at those multiple constraints, such as tooling and operators. In addition to that, you not only have to look at the internal capacity and availability of your resources, but you also need to look at your material constraints. So that means combining the availability of your materials either on stock or on purchase orders in order to schedule accordingly your production orders. And so that comes also to that point when you want to schedule quickly. So when comparing to manual scenarios, you really want to have that answer from the system much quicker, and that's what the scheduling engines are about within the APS systems. It's about updating your schedule, adding the new orders, getting the actual production that has been committed into your schedule from your ERP system, for example, as well, and then replanning quickly to see the effects of the changes. So Preactor as a Siemens solution has been developed about 25 years ago, and actually all of those problems that we talked about a minute ago were actually something that initiated the preparing the software itself. So it was really built based on the requirements that were coming from manufacturing companies that required a better way to do the planning, and it's been very responsive in terms of also changing views and putting new logic such as scheduling rules into the system over the years. Basically, SIMATIC IT Preactor is an advanced planning and scheduling solution. So we try to distinguish between scheduling and planning, and it might be worth just to give you an idea why we distinguish those two terms. Scheduling is really about sequencing of orders and operations onto your individual machines. So this is the work of the planner that needs to be done every day in order to be able to distribute the production plan to your factory. That includes looking at the machines, it includes looking at additional resources such as operators and tools. Most of the companies that we meet, the first thing that they want to solve is actually the scheduling problem, because without going into that detail, there's really no point of going back in order to look at more general view. And more general view on that, let's say, strategic level in the longer term is really what we do in what we call advanced planning. And advanced planning is really looking at your forecast, not a very detailed view of your machines, but maybe a group of your lines and group of your machines. Inside the advanced planning solution, you can look at your proposed stock levels and how to meet the future demand. You can take into account some of the basic constraints, but also it takes a look at, so for example, things like material shelf life, which might be interesting for companies, for example, in the food manufacturing. So we distinguish those two types of solutions, and today we will be looking mainly at the scheduling solution to deal with those problems that we've highlighted in the first phase, in order to be able to manage your production that is more closer to home, to the planning departments on a day-to-day basis. So within that planning and scheduling solutions, and this is mainly to do with the scheduling here, are those key functionalities that have been built in order to look at those challenges. So for example, modeling the actual production capacity. This is about putting your machines, your operators, and the tooling into use when you plan your resources, but also take into account the material control. So within Preactor, you can do what we call material control in order to check, based on your bill of material, do you have all the materials that are necessary in order to start your production order. So for example, if they are available on stock or they are available on the purchase order. In order to speed up the planning process, we include scheduling rules. So this is a scheduling logic that gives you a possibility to apply across different production orders. You select which production orders are to be put onto the planning board. What I will do in that live demonstration, we're going to see one production order that will be scheduled, and then we're going to schedule everything using, for example, a due date performance. So when we actually need to deliver those orders. And you can combine different scheduling logics within the system for different types of products, different types of orders. as well. You can run what-if scenarios, so you don't have to agree to one scheduling scenario. You can have different types of schedules that you will generate using different scheduling rules, and then once you are happy and you compare them, for example, using KPIs, you can compare them and select the one that you want to send back to the ERP. Another part is when we can deliver this order simulation, so all the order inquiries that you can put into, say, for example, taking into account our current planning and current usage of the resources, when we will be able to add this new order, or what we need to do in order to reschedule. And also to include material control.
This is exactly those cases when a new salesman is coming, shouting, I want to get an answer from the planner. When can I expect, or what is the date I can say to the customer that the order will be delivered, right?
Yes, that's exactly what we're trying to do here. Of course, we try to minimize the shouting aspect here, because we try to put it inside the structure, because if you try to put a planning procedure, when you actually look at the batch of orders, and this is exactly what this customer in question did, they put a planning procedure to actually see more than one order inquiry before they accept those order inquiries, because those order inquiries can also have different priorities. So that's the basic functionality that you can expect from the system. We will see some of those elements here during the live presentation. I've mentioned that the need for integrating with the ERP is one of the most welcomed by manufacturing companies, because you don't really want to re-implement or add another ERP into your system. If you have already an ERP system, or you're looking at new ERP solutions. What is important here is the example where we take the information concerning the work orders, your bill of material, your routing from your existing ERP system. We schedule them in Preactor, we set out the production plan, and then we send back the schedule into the ERP systems. One of the examples, and because working closely with Columbus, we've had those examples of integrations that are really available out of the box. So, for example, if you are already a Microsoft Dynamics AX or NAV customer, you can have that integrations really available for you. And what we do here is that we try to complement the ERP, such as AX and NAV, with that additional scheduling logic. Okay.
Maybe to highlight, Michal, that this is just standalone system which can be integrated with the current system ERP, what the customers have. So this is kind of in the middle of the process. So you're just adding on top on what you have, so-called legacy system.
Yes, and what we try to do is that we really try to supplement the existing functionality. So, for example, you might not have a scheduling module in your ERP system, but if you, for example, have already an MRP engine that you use, for example, to generate your production orders or generate suggestion purchase orders, we try to take it away within the scheduling system. You should use that functionality as you have it now, but you should add those additional functionalities that you can get out of a scheduling system in order to have those two systems working together. Just a couple of comments concerning the user base. So you will have again, as I said, you probably represent different companies. You represent different companies with different industries. There is really not one dominant industry across a user base of Preactor software. This goes back to the flexibility of the system, when we can change it and we can modify it with additional functionalities in order to be specific to different scheduling requirements. We've been working in Baltic region with Columbus, as David has mentioned before. We have the implementations together. We also have a case study together where a customer from Lithuania has described the way they were doing their process before Preactor, how the implementation was performed by Columbus, and then what kind of benefits they have achieved. And we can have this material for you available as well. Because Preactor is a part of a Siemens and what we call it manufacturing operations management, so this is different applications that really deal with the manufacturing world. By choosing Preactor, you also have that support from the Siemens team and competence center based in UK that can provide also some support, and we provide this support also through the partners that we work together in. Davidas, any questions that I need to answer? I'm just looking at.
No, I'm just writing down for the group to see what are the questions type. So please go ahead.
Okay. So once we talked about a little about the problems, we talked about the basic functionality within the system. So let me just go ahead and do a little bit of a presentation of Preactor as well. I wanted to concentrate really on a couple of planning scenarios that are typical for manufacturers that are in that make-to-order environment of having those orders, and we have to look at different connections between the orders. So we're gonna see a structure, an example of a production process that includes multiple levels in the bill of material. That gives you additional challenge within the manufacturing and production planning, because you have to, in a normal life, you have to synchronize this across different departments, and Preactor role is also to synchronize all of those different production orders together to come up with that last end date that will show you how you can when you can finish that specific order. So we're going to deal with how we can plan all of the orders. Then we're going to choose one of the orders to have a high priority, so we can see that we need to replan, and what we'll see is also the consequences of that replanning. I will put some breakdown so you can see what changes if we add a breakdown, and how you can react and how you can replan. And also we'll look a little bit about material connections. So for example, connecting the connected work orders to the purchase order, and what happens if the new dates arrives. And lastly, we will switch to a different type of configuration, and I will show you an example how can you combine the due date performance together with minimizing the changeover times. So let me just add here a screen when I want to share my screen. If you could hold on a second.
Yeah, it's coming.
Hold on. Now, for your viewing information, you could also make your full screen. There is if you look on the right side of that screen where we're sharing, you can do a full screen. So you can see the system in a little bit more details if you want. So let me introduce. This is the planning board. So that's the place where the planner spends most of their time in. You see a classical Gantt chart where on the left side you can see all of the workstations or all of the resources that we will be planning on. So that could, in that example, these are the cutting lines, these are the milling lines, CNC machines, welding stations, assembly stations, but also we have something which we call the subcontractor resource. So for example, we have a painting resource here, which will give you the possibility to plan your subcontracting work. So for example, if you have a subcontracting inside your process and you want to know when you're going to send that specific part of the order to the subcontractor and when you can expect it back, you would usually use a subcontractor resource to do that. And then finally, we have some packing lines, which are here to show you the final process. We have a couple of sales orders that are also visible here. At the bottom of the screen, you have an order quantity that is required for that specific sales order, and you see what kind of customer that is, and what is the final part, and more specifically, what is the demand date, which means when you need to deliver that, and when you need to deliver that order. In the unscheduled operations, Each of these bars represent a single production order that is required to be scheduled. So, for example, here I have my final product with my final assembly, and this would be an operation called assembly. And before that, after that assembly operation, we would also have some painting that will be done in the subcontractor, and also the final operation of packing. All of those operations, so we want to do the assembly, but of course we have to do also the sub-products before, and also cut some details on those cutting lines. So what I'm going to do now is that I will select a bunch of orders, and only those orders that are connected together because they are connected to a specific sales order will be shown here. And if I select one of the orders, let me go a little bit back, and let me pick one specific detail that I will move now manually into the planning line, onto the cutting line. And let me do a little bit of scrolling just to show you the visualization part. So here is our production schedule. We have our setup start time and end time that is established based on the routing information that comes from your ERP system. So that's the element of the detail that will be cut on that specific line, and I just did a little bit of a manual planning. So if I was a planner and I really wanted to do that manually, which we obviously don't want to do because that's why we have those automatic functions, we would add those orders one after another onto the planning board. But as I said, we don't want to do it, so we want to really plan the full structure. So what I'm going to do is that while I have selected this specific sales order, when all of the connected production orders to that sales orders, I will just put it onto the planning board. So now what we have, and let me put a little bit, hide some of the resources. We also have on those resources the specific calendars. You work on one shift, or you work on two shifts, or maybe if you work on 3 shifts. So that can be customized as well. What you can see here is that we scheduled the whole structure. So for example, in order to start our assembly, if I highlight previous operations, you can see I have some sub-products that will go into my assembly. So whenever I have production orders that are connected because of the bill of material, they will be connected because we take into account that structure, and this will be done automatically while you're doing the scheduling in order to show you the full flow of the operations from the start to the last operation. So again, if I highlight that specific order, you can see that I have some subcontracting and painting. I will start some packing before the weekend, but then I will finish it after the weekend, and I have my end time of that specific production order that was generated based on planning all of these structures together. You can see there is also a connection to the specific sales order, and if you want to view the connections between those production orders in order to see what kind of materials we need and which orders are connected together, what you would usually use is what we call the Material Explorer. So you should be able to see a Material Explorer now. Yes, you can see that, hopefully. Yes. So Material Explorer, it shows you all the connections between different production orders, and it adds that additional information concerning your materials as well. So in that case, we start with the sales order, which is on the right, where we need to deliver our final product on the 18th of April. We have our final product, which would be assembled, packed, sent to painting and packed. And then we would have information concerning all of the sub-products that go into that specific final product. And that would include all those parts that need to be made before we can start our assembly. We can also go into the details of that specific production order. So this is a production order for our sub-product, where we can see that we will be using some of the details, but also we will see that we will have some materials that are needed. And you can see in that case, we have a material that is needed and that will be available on stock. And we will link the material against the production order. If I go and have a look at one of my details, I have here an example also of a detail that will be cutted and then it will be sent, it will become material for that production order will come from stock. But also in my schedule here, I can see that some of my lines, so for example, some of my details cannot start earlier than after the weekend. So, sorry, not after the weekend, but on the 13th. The reason for that is that I have a material 7 that is coming in, but it will come with the purchase order on the 12th. So that means that we have connected the production orders not only to the materials, but also to on materials on stock, but also materials on the purchase order. And so when this material will be available a little bit later on, then we can connect that detail, and so the materials will also influence our schedule in that way. So we have scheduled a single order, but what you really want to do is that you want to remove that order from the schedule, and then you want to schedule all of the orders. And what I'm going to do is that I will simply generate the schedule using a rule when we want to schedule all of the orders according to their due date. I also want to change a little bit about visualization of the schedule. So for example, I want to see the colors based only on the sales orders. So I'm going to change the bars here to show you the colors based on the sales orders. So if I highlight a specific sales order by highlighting one of the work orders, you can see that everything is in red, which means the color of that specific bar will be the same for all of the bars that are connected to the sales orders. And that's usually very important for the planners who are very on a visual side when they want to see those different connections using different colors. So what we're going to do now is that we're just going to generate the schedule for all of the orders, and you can see that we generated the schedule for all of our orders. And we are basically looking at our packing lines just to check that all of the connections are good, and all of those connections are placed on the planning board. In that case, when you want to go into that some of the details, one of the details that you want to see is what kind of problems you have in your orders. So in that regard, when you want to see that if everything is okay or not okay in regards to what is your lateness and what is your due date performance. Here we show just the final products, so final assembly for product 2 and product 3. And in this case, on that table, you should be able to see that we have an order end and we have a due date. And if we are exceeding the order end, so we are making this after the due date, we will have some lateness, and so those orders are shown as late orders. I can highlight those orders. I have some additional analysis for that order. But basically here I can see that this order is potentially late, and there is additional visualization that shows you in the red color to show you that those orders cannot be made on time. Let's assume that we actually want to make that specific order on time, and we really want to keep that due date. What I will do first before we do that is that we will unschedule everything. I will now select the sales order 2 that I really wanted to be first onto the planning board. So if I schedule that, you can see now that this will be done on time because it's not late. It's got all the capacity that it needs in order to be made on time. But what happens next is that I will add all of those orders after that, and I will do the refresh. And what you can see here now is that while we have actually put that high order priority order on time, we actually at the same time made one of those orders late. And there is additional window that shows you the analysis of changes. So whenever you do 2 versions of the schedule and then you reschedule, you can actually have a list of all the changes that will happen in the production schedule as a result of the change that you have made before I hit generate schedule. And in that example, you can see there is a warning for our final product 3, which is now late, and we made it late because we speed up one of the orders that we wanted to put as a higher priority order. This shows you that you can see before you send the schedule back to your ERP system, you can see all of the effects that will have if you make those kind of changes such as higher priority orders on your overall due date performance. So when we have those scenarios within the customer, when you have a salesperson that comes in and asks you, okay, but we really need to make that order on time, what orders will be made later if you put that order in a higher priority state? This is exactly what the planners would do. They would do a quick rescheduling, they would put a higher priority on one of the orders, they would add all of other orders after that, and they will come to the sales department with an answer. Here is the consequences of the move that you want to make. These orders will be made late if we speed up that order. And imagine you have a situation when you see your plan for the next 2 or 3 months. Because when you want to see only your next week, when you do those manual changes and manual Excels, you might not see the effect of putting that order first on all of those orders in the next 2 or 3 months. With Preactor, because you can reschedule this quickly, you can have that answer in a quicker way. But let's say that
Michal, in this case, I would say if you would have this shouting salesman kind of request about the delivery date, so you basically can do that in 10 minutes easily. And you have actually showed that for the planner, he just rescheduled, and that took for him like 2 or 3 minutes to do that.
Yes, so that's basically one of the scenarios that people would do very well. If you try to see the consequences of that changes, this is what you would this is what you would do. And of course, also when we talk about those different changes that can happen in your production, what you want to know is that how this due date performance will be affected if you have those different problems that you cannot anticipate. So for example, a change in the material date. So let's say that we have an example here where we have our purchase order, and let's say that we received information that the purchase order will not be made available for us on the 12th of April, as it was promised by our subcontractor or our delivery. And let's say that this will be moved into the 2nd of May. So now you can see that the purchase order, by changing this manually, and of course this date would usually be downloaded from your ERP. What would happen now if we do repair the schedule? You can see that all of the orders that are affected because of that change in the material delivery date will also be shown you on that quick analysis window. So that change will also affect some of our different products. So if I go back and I do a refresh, you can see now that I end up with many different products and final assemblies that are affected because of change that changing the purchase in the purchase order. And if you know that in advance, of course, and if you keep that connection with your subcontractors, when they will feed you with the information when they actually plan to deliver these purchase orders, then you can manage your production schedule in a much better way.
Michal, I have one particular question which I accepted. So would you like to answer? The question is, if material orders do not support meeting required demand date, what happens then?
If they do not support in terms of, so for example, this is exactly the scenario that I believe we showed, which means that you want to have these materials on the 12th, but you don't get those materials in time, then the change is happening in the schedule when you push those orders that are affected by the lack of that material.
Exactly.
Is that? I hope it's the right answer for that question. If not, if something is more.
This is the way I understood the question.
Okay, so that's why. So you had a required date of that material order. This is not met. You have that information from the ERP system, and then you have the rescheduling, which you see how it affects your production plan.
And this is exactly the same. It relates also to raw materials. So it doesn't matter what. I mean, purchase order can be for whatever is needed for making your final product.
Exactly. That's the way
we have 10 minutes left, so we have to kind of.
Okay, we try to speed up a little bit just to give you one more scenario here, and then we're going to do this quick change to that optimization. So let me just show you what happens if we have a breakdown. So if we have a breakdown, we're going to enter this manually. We have a breakdown information here. When we will say when the machine will not be available.
So let's imagine that we got information about the breakdown from the kind of production department, right?
Yes. So what happens is that this cutting line will not be available for almost a week, and you can see now that all of the orders that were planned on that specific line will actually be delayed. If you decide to delay that, you could do a repair schedule, because now you have to move all of the sub-products into the future. So you can see how all of those sub-products and final products are moved in time. But because you have that alternative cutting line and the system knows that this is alternative, what you would usually do is you will do a quick reschedule. When you generate a schedule, and then this cutting line too will be used more because it's available. After that week, we still have some demand on the cutting line 1, but at the same time, we again can see and refresh the effects of that change in order to show you exactly what would be the problem with delivery performance once you have that specific breakdown. So there are just a couple of scenarios that you would want to deal with the schedule. Of course, once you commit the schedule and you send it back to the ERP, you have a production plan report to show you exactly what happens on the sequence, on the resources, and then after you commit the quantities in your ERP system, they would be downloaded into the system, and you would see an updated schedule with the actual production. And then again, you can react to see what are the changes, and if you have a delay in the process, again you go back into that delivery performance. So in those scenarios, it's very important to look at delivery performance and how it's affected by different changes. Now, most of the companies that would really have a mix of situations. So you might be a make-to-order company, but you will have you have a make-to-order and make-to-stock scenarios. And when you have a make-to-stock scenarios, you also want to do a little bit of optimization on some of the resources. Here is a very brief example on how you can do it. So what we're going to do is that we will have 3 planning and scheduling scenarios. The first scenario would be just to plan everything using a due date performance priority. On the top of that window, there is a window that shows you key performance indicators. So, for example, how many orders are late, but at the same time, it shows you how many hours of setup time we have accumulated in our schedule. So in this example, we just take care of our due date, but we don't look at the optimization of the setup times. And in this example, the optimization of the setup times is done if you choose to do a preferred sequence scenario. So what we're going to do is that we will try to minimize the setup time by combining similar products together. So you can see that they are combined by the same color of that order, because that influences the setup time. If you change from black to white, from white to black, it's 30 minutes of a setup time. But when you change from white to black, or red, you might have 3 hours of setup time. So if I want to do a simple, from black to white, yes, sorry for a mistake. So what you can see here now, if we do a preferred sequence rule, so we try to optimize the setup times and minimize the setup times, you can see that we have minimized the number of setup times to 14 hours, comparing to 97 hours before, but at the same time, we have increased the number of late orders to 47, which might not be really the scenario that you want to go. It's going to be logged by the production, but not really from the sales department perspective. So what you want to do is that you want to combine those 2 priorities. And one of the way to combine this is, for example, to use a campaigning approach. When you group the work orders based on their due date, so in this example, we will group all of the production orders that will be needed to be made in the next week. We're going to group them together. We're going to minimize changeover times between those work orders. Then we're going to move to the next week. So all of those that are needed in the following week, we would minimize those production orders together, and that's how we will arrive at the schedule.
So in this case, kind of time, we will try to look for a compromise between the production department and the sales department.
Yes, exactly. And what you can see here is that when we do that minimized setup time within weeks, we have a higher number of setup hours comparing to the preferred sequence, but lower about 40 hours comparing to our due date performance. And at the same time, we have increased the late orders by a couple of orders, but not that much comparing to that preferred sequence. And all that is done on the same set of data with different scheduling logics, and you can decide which scheduling logic is right for that schedule, and then you can decide which of those scenarios you want to accept and send the data back to the ERP. And this is basically a way of looking for that compromise between optimizing the schedule and trying to do delivery performance. So that's the part of the short introduction and a short showing you of the system. We'll go back into the slides to finish a little bit on the benefits that you can expect. I'm already sorry for.
We have 4 minutes left.
I'm very sorry for extending a little bit our time that we needed, but let me just go very quickly on that. So we are going back to that real life example and that success story that the company requested. So basically, what they wanted to achieve was to put in a central schedule. And you can see from that presentation, when we were doing that first example, we actually have a lot of different departments that were put together because of the way we can synchronize the orders between different departments. And that's how you achieve a central schedule. You're looking across all of your processes, from your materials through the production orders to your sales orders. They were able to acquire the visualization, the flexibility in the system by looking at this visualization that I just showed you. They could have some way of interacting with the schedule. They believe the planner is always right at the end, but of course they were able to automate most of this using those different scheduling logics. And they were able to optimize the just by using those minimizing changeover times rules, combining with our approach for campaigning. They also wanted to introduce the priorities, and this is exactly what you can do in the system. You can have priorities against the work orders and also against the customers, and you can use that in the scheduling rule. And when they put that on paper, and they also accepted the case study, so they actually talk about how they were able to get more out of this changing requirement situations that they had, and how they were able to react quickly to that change because they changed the process and they used a better tool. They were able to introduce the planning procedure, a very strict way of looking at what happens, and during the implementation we also try to sit down with the companies and to write the planning procedure, what should happen one after, what should be the sequence of the events, when you update the orders, when you send it back, how you interact with different departments, but also what data needs to come from those different departments to the schedule and who will be responsible for that. So you can see that they not only use the tool, but they also change the process. And this is exactly how their process looked after. You remember those 72 hours that I've mentioned before when they needed to wait for the answer from the planning department? Now they have a central schedule, which is based in the first department, because from their point of view, it's the one that creates the most possibilities for optimizing the cost because of the sequence dependent times. They really have a central planner, as they call it. The other departments are really used just to exchange some information. So for example, dealing with some exceptions. But what is important is that using that planning procedure, using the power of Preactor, they really could, within hours, which means I think the goal was to have it within 4-hour period, to have that answer when we can deliver that specific order, and also to keep that promise in the future. So that's how their process looks now and how it looked after the changes that we made. And again, looking from the general point of view, what kind of those benefits you can expect from introducing Preactor system. One of them would be specifically inside improving the planning process. So dealing with all of those challenges that I have mentioned before, by automating the process, by putting more details into that system, but making the system responsible for dealing with those details. We had a customer that reported in their case study that they were able to reduce about 70% of time that was needed to actually prepare the production plan before. So if they spend it, let's say, a full working day, they were able to really reduce this just to two hours in order to have all of those different scenarios and to accept the schedule. Because of that scheduling rules that we used, you can also look for improvements of productivity by better use of the resources. And can be either your internal resources by having those minimizations of changeover times, but also better use of subcontractors. And we have a case study where the customer has said that because they can see the plan in a longer horizon, they were able to better synchronize the work between themselves and also the subcontractors. And but that they were able to also gain some improvements. In regards to this customer service, which we really highlight, on which I believe we really concentrated today, there are companies that are committed to say how they improve their delivery performance. But it's really about how quickly you can get the feedback back to the sales department. Not only if you will be able to make it on time, but also if you are not able to make it on time and why. Just as I showed you this on the scenarios. So that could lead, for example, to better management of that information, and also in some ways to decreasing the cost of the delay. So for example, if you really have to expedite the orders very, very quickly. And the last point is really about the material management. I showed you how those material connections are influencing your schedule, and that could be a way also to look at your schedule and then prepare the material availability based on your production schedule. We have case studies of companies that were able to do it. They produced a feasible, workable production schedule, and then they synchronized the material availability, so synchronize the purchase orders against the production schedule. So for example, they don't have to have that big stock of those metal parts every month because they know exactly when those parts will be needed on their resources. And also a make span reduction, and we have example of a customer that by better synchronization across different departments, they were able to decrease the overall manufacturing span. And that's basically when you change from a situation when the operators are picking up different orders to be scheduled next, because when you use the production plan, you can exactly see what is the sequence, and that should also lead to the general improvements in terms of the in terms of the lead times. So now we really want to do, if we have any kind of questions that we want to delay at the end, Davidas, I think you can take charge.
Michal, I would say there is no time left for the questions. So in this case, I'm saying thank you everyone for participating. You see on the screen the emails, and those emails you also be able to download with our slides. So what I'm saying, please do not hesitate to send your questions to the emails, and if you see that some of the emails of the questions we can handle by separate presentation or individually, we will do that. We'll do that immediately. So I'm saying thank you once again. I was really excited to be a moderator of this webinar, and I'm saying have a good day though to everybody. Thank you.
Thank you.